Hello and welcome to 5.4 Rational Numbers and Real Number System. So let's get started by looking at some examples like problem set 1, simplify the radical. So with these square roots, you're going to have things that can multiply together inside these radicals, and the two numbers that repeat in multiplying, or that would if you were to multiply together to give you the number, that's going to be the square root. Like 68, you can think of that as 8 times 8 gives you 64. Or that 8 squared yields 64. And you can think of the square root, this is square root that we see, and this cube, or this square that we did to this 8, as inverse operations. So the square root of 64 is going to yield 8. And if you look at number 2, you can actually break the square root down into two separate pieces. And the square root of 1 is 1 because 1 squared is 1. And if you look at 36, well, you can think of that as 6 times 6 or 6 squared. So if you were to take the square root of that, you would just be left with 6. Okay, looking at something like number 3, anything that you have a negative under the radical, that's going to yield not a real number. If you take any upper level math courses, you will find that that's going to be called an imaginary number, and there are all sorts of rules and regulations in math where you can use those, and they're pretty applicable. Looking at one like number 4, again, let's break down that fraction by breaking down the square root. So we broke it into the numerator being square root of 1, and that's just going to be 1. And then square root of 121, two numbers that multiply together to give you 121 would be 11 and 11, or 11 squared. So the square root would be 11. Looking at number 5, let's break down that radical. So we had the beginning the radical of 361 divided by 36. Now we're going to break it into the square root of 361 divided by square root of 36. And two numbers that multiply together that are the same number that give you 331 would be 19, because 19 squared gives you 361. And 6 times 6, like we said before, gives you 36, so taking the square root of 36 would just yield 6. Also, it's important to note that that 0, because 0 squared is 0. So to do the inverse operation of a square to the square root, you're just going to get 0. Here are the product rules for radicals. If the square root of a and the square root of b are real numbers, then the square root of a times b equals the split up square root of a times square root of b. So to do the problem set of 2, use the product rule to simplify the radicals. Try to break these into the perfect squares. Like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100, and 11 is 121, and 12 is 144. So try to break these things on the radicals into these kind of numbers. So you can think of 20 as being 4 times 5. And I like to think of these as being multiplied inside the radical, and then break these radicals apart even farther. So, as we can see, that this would be 2. So we can make this square root of 4 into a 2 and leave the radical 5 attached, because radical 5 cannot be broken down any farther. And I'll go ahead and write these over here. These may be important to know later on. And you're going to try to break down anything inside a radical to these kind of numbers. Okay, so moving on. If we look at 179, I believe you'll see that 179 is not factorable into perfect squares. Because if you were to take 179 divided by each of the numbers we just wrote in the previous slide, you would not get anything pretty. It would have decimals, and you do not want to work with that kind of material. Looking at number 3 with square root of 90, you want to break that into 90 being the product of 9 times 10. Break that down even farther into the square root of 9 times the square root of 10. Square root of 9 can be broken into 3, and then just leave that square root of 10 attached because there's nothing else you can do with it. With number 4, think of 72 as the product of 9 and 8. And separate these farther. The square root of 9 is 3 times, and what happens here? Well, 4 and 2 can break into 8. So 4 was on that magic list of perfect squares. So you can actually pull 4 out as a 2. Pull 2 out of the radical. But this other 2 has to stay because it cannot be broken down any farther. So this square root of 8 transforms into 2 times square root of 2. And this can be broken down even farther into 3 times 2, which is 6 square root of 2. Number 5, let's break down what this means. We have 4 from the outside of the radical times the square root of 20. Okay, now let's think of things that multiply to give us 20. Well, that could be 4 times 5. And we're aiming for a perfect square, and that's what 4 is. So we have 4 times the square root of 4 times the square root of 5. Okay, and 4, bring it on down because we haven't had anything with it. Square root of 4 is 2 times the square root of 5. Now just do some simple multiplication. 4 times 2 is 8, square root of 5. And for the last example of the product rule with radicals, let's think of this negative 9 times the square root of 12. Let's aim for things that multiply to give us 12 within terms of square roots. So 4 times 2 gives us 12. So let's break this down even farther. Negative 9 times square root of 4 times the square root of 3. So this can be broken into negative 9 times this square root of 4 can be broken into 2 times the square root of 3. Let's multiply the negative 9 and the 2 together. We get negative 18. Bring that square root of 3 down, and that is the final answer.